Good day, students. In this video, I'll be teaching you how to ace your physics IGCSE practical examination. That is your paper 6. But I'll be focusing on question number 4 of your paper 6. Okay? So I will try to touch up to 4 different exam sections. I will focus only on paper 4. Okay? Then I might just quickly go through the other classes, the other questions. Take note that this is the Cambridge specimen question paper for your 2023 examination. Okay, this is your question paper for 2023, your specimen question paper, and that is what you'll be working on for today. And I have your question paper here, so you just go through it. We go through the examiner's report on each question. Let's go straight to question number 1. So this is question number 1. This is the original question. Okay, this is question number 1. So this is the marking guard. Okay, and you can see the question. This is just a sample. It has the format of the answer given by a student. Okay, you can see question 1. The student selected 20.1 degrees Celsius. Okay, but take note that emphasis of this video is on question 4. Okay, so I will just go straight to question number 4, which is what I produced this video for. I will talk about question 4. Okay, yeah, using this sample, this is question 4, and let me go to question 4 of this original question paper of your specimen paper, question 4, planning. Yeah, so now you learn how to plan exam. Let's start with the first one. All right, the question. A student is investigating the factors that affect the size of the crater, that is the hole a ball makes when it is dropped into the sand. Plan an experiment to investigate one factor that affects the size of the crater. Now, let's go to this. The apparatus available enclosed. These are the apparatus available to you. Now, you have to write a plan for the experiment. Your plan should, now, you see these bullet points here? These are the points that you use as a guide to answer this question. As you are answering each of the questions in the bullet points, you are already planning the experiment. So that is what you write down here, okay? Just write down all this, what this bullet point requires of you. Let's start. State which factor is being investigated. So now let's look at what this student answered. This is the question, and this is the answer the student gave. Now, this is what the student says, that the student should investigate how far a ball drops into the sand. Now, I believe that after reading this question, you understand what we are doing here. When you release a ball from a certain height, and then the ball falls down, let's assume this is ground level. Once this ball lands on the ground, this will create a crater, that is, create a hole. If you release the ball from a higher height, that you raise it higher, and it falls through a higher altitude, once it lands on the ground, it will create a bigger hole. Okay, it will create a bigger hole. And if you are releasing it from a shorter distance, like from here, then it will create a small hole. That is what happens when objects fall into sand. Okay, take note that it is falling into the sand. Now you want to get the effect of, now we are trying to get the effect of the height of release on the size of the hole. So what you need to measure is the height, the vertical distance. You use a meter rule to measure the height, okay? Then you use a meter rule to measure the width of this hole, or you use a vernier caliper. So any instrument you want to use, you just need to know the diameter of this hole, okay? Then you need to know the length or the height from which the object was released. Those are the two values you need in your table. Those two values are very important. Now let us see the response this student gave to this question, and this will guide us to know mistakes that we need to avoid. Now the student goes by saying a student will investigate how far a ball is dropped. This is already in the question. You don't need to state statements like this. You should just go straight to the procedure. Okay. Number one, which factor is being investigated? You are trying to investigate the width of the hole. Then state key variable to be kept constant. What will you keep constant? The mass of the object. So you just go straight by producing answers to these direct questions, and that is what we do here. So he then says he will need a meter rule. Of course, that's fine. As you are listing your apparatus, do not list any apparatus that is given in the question. Okay, And in the apparatus given to us, we have a tray of sand, then we have metal balls. Do not list metal ball or tray of sand in the apparatus, okay? Then you must use the same metal ball, that's fine. He will throw. He said he will throw the ball. No, you don't throw the ball, you release the ball. You release the ball so that it will fall downwards due to gravity. Okay, if you are throwing it, that means you are pushing it downward. How do you measure the force with which you throw it? So you have to use the appropriate verb in this section. When it comes to planning, you must use the correct verbs. Now let's look at the examiner's comment on the student's response. So I've highlighted some points. This page says mark 4 points is not scored. Let's start here. This candidate starts well, of course, that is a very good thing. The list of apparatus contains additional apparatus required but unnecessary. Unnecessarily also includes apparatus already specified in the question. So you don't specify apparatus that have been specified in the question. You will need a meter roll, a clamp, a stand, a tray of sand, a metal ball, tray of dry sand. All of these, they are already in the question, okay? You don't list out a metal ball, a tray of sand. So you don't list apparatus that are already in the question. These are mistakes that students make that do not earn them any mark, but instead waste time that they could spend on other things that will earn them good marks. So you don't list out apparatus that have already been mentioned in the question. What else do you have? Okay, what else do we have here? The result, the result in a rambling account, which often causes, okay, these are mistakes that many students make. These are common mistakes, okay? These are common mistakes that students make. That is what we want to talk about now. Common mistakes that students make. You know, you talked about the mistake he made. He said he will throw, and that is not correct. He was supposed to say the ball was being dropped from a certain height. So you must use the correct tenses, the correct verb. It's clear, right? Good. Also, what about your precaution? List of precautions that are irrelevant or not specific to this investigation. So when you are stating your precaution must be very important. It must be relevant to the investigation at hand. Now let's look at this. What did the student say? Yeah, he must be careful not to drop the ball on his foot. Well, that is good. He must not spill the tray of sand. Yes, that is also fine. It is important to look at the ruler at right angle to avoid parallax error. Well, when you are stating your errors, you state precautions that are very specific. Don't state precautions that are general. Now let's look at this, for instance. When you talk about this parallax error, you know you can avoid parallax error on the hour meter. You can also avoid parallax error on the voltmeter. So errors that are general should not be stated. Only state errors that are specific. So in this case now, you do not avoid, you use the same ball. Yes, you use the same ball throughout your experiment. So if you have said a single ball must be used throughout the experiment to avoid varying the mass of the ball, that would be a better precaution. So we've looked at common mistakes. These are common mistakes. Candidates often write too much. Yes, candidates often write too much. Most candidates write too much stories. This candidate has written a very long essay, though it could have been better if you had used bullet points. Bullet points helps you to avoid making too many statements. Like you list your procedure, okay, list them out instead of writing very long continuous essay. List out your procedure. It helps you to avoid writing too much. Okay, so that is it. That is it. Talking about common mistakes, that is it. That is good enough. So avoid mistakes that other students make. General precautions that apply to most experiments. Example, how to avoid parallax error are not required. Okay? They are not required. So the precaution we expect in this case, something like this. In this investigation, flattening the surface of the ball before each trial. Perfect. You see, so talking about flattening the surface of the sand, rather, flattening the surface of the sand, that is good because after each trial, you have to ensure the surface of the sand is flat. Once this ball lands in the sand, it creates a crater. Okay, so what will you do? You flatten it, clean up the crater before throwing it again. So that precaution is very specific to this particular experiment. So those are mistakes students make that make them lose marks. Okay, and if you avoid this mistake, you earn all the mark and earn excellent grades. So that's why I use this sample to explain all of this to you. So you see mistakes that students make and you avoid making such mistakes. Let us go through some years. Okay, this is a sample of 2023. Okay, for those that will be writing this exam in the year 2023, so you avoid this mistake. And this 2020 curriculum also covers papers that will be written up to 2025. So that is it. That is it. You have answered this question. Okay. Now let's go to, we have talked about mistakes to avoid. Okay, good. So that is clear, right? So that's it. What else do we have here? That is all. This is clear. Maybe just go to another year and then talk about the question answered in another year. Even the end of the question tells the student to do some other things. Suggest suitable graph. Suggest suitable graphs to be drawn. Okay. State how to obtain reliable results from this experiment. Did the student talk about the graph? The students talk about the graph. There was no mention of the graph. The student just plotted a graph, but there was no statement saying plot a graph of height against diameter. Of course, height against diameter that he did here is correct, but he was supposed to state it that plot a graph of height on the vertical axis and diameter of the crater on the horizontal axis. Also, the student did not talk about how to tabulate his results. Okay, that's another mistake the students made. The student was supposed to talk about tabulate the results that you have height in meters, then the diameter in meters. Okay, so these are ways that students lose marks unknown to them. Let us pick a certain year. Let us pick the May June year 2021. Remember, our focus is on paper 4, so we'll be focusing only on paper 4. So let's go to where this question was answered. Okay, but why? Okay, we've gotten there. This is the question. So I just have a blank question paper here. Okay, so you can read the procedure together before going into the answer. So this is the question. A student investigates the rate of cooling in air of heated metal blocks made of different metals. The temperature of each block is increased by placing in hot water. You know, this procedure has already told us, the question has already told you that you have to place the objects in hot water. Now you have to plan an experiment to investigate how the rate of cooling depends on the metal from which each block is made. The following apparatus is available to the student. Now you have been provided with all these apparatus. Remember, you have your thermometer, you have cylindrical blocks of different metals. When you are answering the question, do not list any of these apparatus in your answer. Now, other apparatus normally available in the school laboratory can also be used in your plan. You should. Now, this is where you provide your answer. List any available apparatus. So you just come here and you list the apparatus. If you are using a stopwatch to measuring the time, put it there. A stop watch. Okay, that's it. You have provided answer to that. Then you go straight to the second question that says, explain briefly how you would carry out the investigation, including the measurements you take. What are the measurements you take? Take note that after removing those four objects, let us assume that okay, now let's visualize the situation like this. There was a big ball, a big yes, there was a big should I say a big bowl or you use a big bath of water? Now you heat four cylindrical objects. There are four cylindrical objects that must be heated in this big bowl. Okay, so we try to space them from each other. Spacing them while heating, does it really matter? Anyway, the most important thing is that you have four big bowls, four hollow big bowls. They have a hole in the center for the thermometer. This is the third, and this is the fourth. So you heat this water to a high temperature, probably 100 degrees Celsius. After that, then you remove these four these 4 metal blocks, remove them from the water bath, okay, and then leave them in open air to cool. So I'm removing them from the water bath and putting them in the open air to cool. Now, in the process of cooling, what should you have? Let us put a thermometer into the hole of each block in order to read the temperature change. Okay, so you want to read the temperature and monitor how each metal block cools down. So there are 4 metals made from different material. Let's assume the first one was made from copper, and the second one was made of iron, the third one was made from aluminum, and the last one was made from zinc. What happens? So as they cool down, let's assume you'll be reading the temperature every 30 seconds. So let's assume after 30 seconds, the temperature of copper has gone down to 87, temperature of iron has gone down to 93, temperature of aluminum has gone down to 82, zinc has gone down to 94. So the fact that the temperature reduces by different amount while they are all exposed to the same condition, but the temperature reduces by different amount. That means the cooling rates of these metals are different, right? So the fact that the cooling rate is different, that shows that the cooling rate depends on the material, yeah, because they are all exposed to the same condition. So we have our answer here. So additional apparatus, I put timer there. Then the second question that says explain briefly how we carry out the investigation, including measurements you will take, and this is the procedure. The first one, remove. So now you don't start by telling us put metal block in a container and heat it. Why? Because the procedure already tells us that you want to investigate the rate of cooling of heated metal blocks. So you have been told that the metal blocks have been heated and they are of different metals. So you just start straight by telling us what you do after they have been heated. The first thing, you remove the metal block made from different material from your hot water. You can use at 100 degrees Celsius. This 100 degrees Celsius does not matter, okay? Just let us know that it's hot water. Then what's next thing? You place them far from each other to prevent interference so that heat does not get transferred between the metals through radiation. What's next? Place them far from each other in a room, insert a thermometer in a hole of each metal block. Then you read and record the temperatures of the 4 metal blocks at time 0 seconds. So in the beginning, record the temperature. After that, you read and record the temperatures of which metal block every 30 seconds. So every 30 seconds, you'll be taking note of the reading. Okay, so these are the values you tabulate. Okay, the time interval must be constant. Why did I put that there? It must have been requested for in the question. The question says, state the key variables to be kept constant. So that time interval of 30 seconds, every 30 seconds, you must do that for all the metals. So the time interval must be kept constant. So you can see everything I'm writing here is an answer to the question. I'm providing answers to the question in bullet points. Once you provide answers to all these questions in bullet points, then you have answered the question satisfactorily. Let's proceed. So, what else do we have here? Create a table of temperature of each and time ranging from 0 seconds to 120 seconds. It should be to create a table of temperature of each metal, okay, and time ranging from 0 seconds to 120 seconds. So yes, now that is the table. Okay, you create a table, you have time here, then you have the temperature of each metal. The first metal is aluminum, temperature of aluminum in degrees Celsius. The second thing is iron, temperature of iron in degrees Celsius, temperature of copper in degrees Celsius, and zinc temperature in degrees Celsius. Okay, what else do you have? The question then asks us that you draw a suitable table. Yeah, sorry, that's what I just did here. The question that says draw a suitable table with column headings to show how you will display your readings. You are not required to enter any reading. So this is just the table that shows how I display my readings. Okay, I'm not entering any values here. Okay, but this is the table. This is the heading, and you have to put the SI unit of each of these. Okay, temperature in degrees Celsius, time in seconds. What's the next thing? And then I said The last question is explain how you would use the results to reach a conclusion. Now this is your table. These are the results, your table. How you use it to reach a conclusion? By plotting graphs. How many graphs will you plot? 4 graphs. Why? Because you took the reading of temperature of 4 different metals. If you have used 3 metals, then you have 3 values for the temperatures, and then you plot 3 graphs. Okay, good. So each metal must have its own graph of temperature against time. Okay, plot 4 graphs, each of temperature of a metal against time. Calculate the slope, that is the cooling rate of each graph. Since these 4 metals were subjected to the same conditions and had different cooling rates. Okay, so after plotting the graph, then you have to calculate the slope. The slope gives you the cooling rate. Calculate the slope, that is the cooling rate of each graph. Trust me, if you do this correctly and you plot the graph and you calculate the slope, you get the cooling rate. Since there are different metals, then they will have different cooling rates. The metal with higher specific heat capacity would have the higher cooling rate. Sorry, would have the lower cooling rate. That means it will cool down slowly. While the metal with the lowest specific heat capacity would have the highest cooling rate. That means it will cool down quickly. That's the effect of the specific capacity on cooling rate. Let's just go on. Since these 4 metals were subjected to the same conditions, yes, they were heated to the same initial temperature, and they were exposed to the same environmental condition, that there was no air, there was no wind, we avoid wind, you maintain your room temperature throughout the process. So and then the cooling rate depends on the material from which the metal was made. Since they were exposed to the same environmental condition and they still had different cooling rates, that means it is the material from which these metals were made that determine the cooling rate of these metals. So that's it. We are producing answers to the statements in these bullet points. So as you are producing answers to this, you are answering the question. This is exactly how you answer question on planning, question 4 in IGCSE paper 6. Okay, you can see we just went straight to the point, and that is it. It's because of the font size. If I have used a smaller font size, you will see that this my answer, everything in the answer would not even occupy half of this page. Okay, if not for the large font size, then the diagram, yeah, the diagrams are also important. So that is it. And once you do that, you have provided answers to your IGCSE paper 4. Okay, as for answering question on paper 1, paper 2, paper 3 and 4, all of this, you can learn all of this by watching the video I uploaded on the YouTube channel, the video before this one. Just watch that video before this very one we are looking at. You know how to answer question on paper 1, 2 and 3. Let's go to another year. We are picking question 2022, your physics 0625. You are using the paper of question paper of October November 2022, paper what? Paper 6 variant 2. Okay, that's the 62 here. Alternative to practical paper 6. Do not forget the name of this YouTube channel is Physics for Everybody. Ensure you subscribe, please. So this is question 1. Okay, it looks similar to what we just did, but of course it's not the same thing as what we just did. So we go straight to question number 4. That is the question on planning. Okay, yeah, so this is the question paper. A student investigates the effects of the resistance of a wire when the tension in the wire is increased. So, how does the tension in the wire affect the resistance of the wire? The apparatus is shown in figure 4.1. So, I'm just teaching you how to answer this question. Okay, I'm not doing it for you. Okay, but I'll show you my answer. Now, this is the apparatus. You want to determine the effects. Okay, the effects on the resistance of the wire when the tension in the wire is increased. So you are increasing the tension in this wire. How do you increase the tension in this wire? By increasing the load. So now this is it. You take this first load here and then you come and hang it here. So when you hang it, the force of this weight of this load, this weight acts downward, hence it pulls this spring. Okay, and through this pulley it pulls this spring, and once it pulls this spring, the wire that looks like this, once it pulls it, okay, the wire will become narrow and longer. Yeah, so that's what happens. The wire becomes narrower and longer once you apply a pulling force to this wire. then it becomes narrower. And as it becomes narrower, what happens to the resistance? The resistance will increase. Why? Because resistance is resistivity multiplied by length divided by cross-sectional area. So as the length is increasing, the resistance is increasing. Since it is also becoming narrower, that means the area is reducing, the cross-sectional area is reducing. And as cross-sectional area is reducing, the resistance is also increasing. So at the end of this experiment, you would use the results of the table to arrive at a conclusion. But since you are not entering any value, you cannot actually arrive at a conclusion, but you can just tell us how you use these values to arrive at a conclusion. Okay, to arrive at a conclusion. So let's just go ahead with the procedure. The procedure says the apparatus in figure 4.1. So you have the apparatus in this figure. These are the masses that you can hang on this on this hook here. And when you hang the mass, the tension will increase. Okay, and when you add another mass to it, the tension would increase again. As the tension increases, the length of the wire will increase. And as the length of the wire is increasing, what happens to resistance? Resistance increases. So let's go. Adding loads to the hook. The student measures the current I in the wire, good, and the potential difference V across the wire. She determines the resistance R of the wire using the equation R equals to V over I. Let's start with this. The student measures the current I and potential difference V. How do you measure current I? Through the ammeter in this circuit, okay? That the ammeter will measure the current. How do you measure the potential difference of this wire? You need to connect a a voltmeter in parallel to this wire, okay? But the question itself will guide you. The question will tell you to do that. So they don't assume you know everything. That's one beautiful thing about practicals. The question will guide you till you arrive at your conclusion. Even in this planning, sometimes the question will guide you. Look at this. The student takes all necessary safety precautions. That means you are not required to write about safety precautions. You are not required. So if you write about safety precautions, you are wasting time that you can invest in answering other questions. The following apparatus is provided. You have your resistance wire, that's this wire here. You have your power source, that is here, your battery or your cell. What else do we have? We have ammeter. This is your ammeter. We have voltmeter. The voltmeter is not in the circuit. Then selection of loads and hanger. So these are the loads, okay, and you have the load hanger. What's step one? Plan an experiment to investigate the effect of the resistance of the wire when the tension in the wire is increased. Okay, you should now, these steps are what you take. Number one, complete the circuit diagram in figure 4.1 to show voltmeter connected to measure potential difference across the resistance wire. Now, how do you connect the voltmeter across resistance wire? Now, this is the original question. So let me erase every other additional information I've put there and focus on answering the question. How do I draw a voltmeter in this circuit? Now, since this is the resistance wire, I may decide to put wires here, okay, to show your connection wire from crocodile clip, and then I draw this circle here that represents my voltmeter, and then I put a V here to represent my voltmeter. This looks correct, but it is very rough. Yes. So when you're answering your question also, you must also consider how neat your diagram would look so that your examiners can see it. So just let me zoom in so I can draw clear, produce some clear drawings. So you just put here, make it clear that you have a junction here, then you produce your conduction wire, put the voltmeter here, then you connect it back. Make sure you have make sure it's obvious that the wires are connected. Make sure it's obvious that the wires are connected, okay? Good. Then you put the symbol of a voltmeter here. When you are doing this in your exam paper, make sure you use make sure your diagram is neat, please, okay? Make sure you draw a very good and neat circle, okay? Don't make it have ripples like this. So that is it. You see, the question will guide you, the procedure will guide you. You've answered that. The second one, explain briefly how you carry out the investigation. How you carry out the investigation? You know, you keep attaching the load, you keep attaching the load. When you attach a load, you know the value of the load you are putting. Okay, you know the value of the load in Newton. Okay, after putting the load, what happen? You measure the current, you take note of the current in amperes. What else do you take note of? The voltmeter is there, you measure the voltage. So you take note of the voltage in volts. What else do you need to read? Then you need to get the resistance. How do you get the resistance? Use this formula to get the resistance. R equals to V over I. So you get the resistance in ohms. Okay. So once you do all of this, this is what your table should look like. Okay. So that's the procedure you carry out when you are carrying out these experiments in the laboratory. Okay, so let us see the way these answers were stated. Let us see the way I stated these answers so that you know how you write when you are doing your exam. So that's it. Complete the circuit with voltmeter. I've done that. The second thing, explain briefly how you carry out this investigation. Now, this is it. Attach a load. Read and record the voltage V, current I, and load L. So you read the voltage, the current, the load. What next? Calculate the resistance R equals to V over I and record the resistance of the wire. So you also record the resistance. What's next thing? Repeat these steps with at least 3 other loads. So you'll be changing the load. As you are changing the load, you measure the current, measure the voltage, measure the resistance, and then you tabulate your values. The length of the wire between the crocodile plates must be kept constant. Why did I write it? It must have been requested for. So the procedure would state what you need to answer the question. The procedure states, state the key variables that you keep constant, and that's why I said the length of the wire between the crocodile clips must be kept constant. What's the next thing you do? Now the next thing is to what? The next thing is to Yeah, okay, repeat the values. Okay, I also say the length of the wire must be kept constant. Yeah, so you have to keep the length of wire. The length of wire must be kept constant. This length from here to here must be kept constant. You must not move it to the right or move it to the left. The length of wire must be kept constant throughout your experiment. I mistakenly erased some part of this diagram. Yeah, so the length from here to here must be kept constant throughout your experiment. Otherwise, you get wrong values, erroneous values. Okay, what's next? The question says, draw a table, yeah, or tables with column headings to show how you will display your readings. You are not required to enter values. So this is my table. What's the next thing? Explain how you would use your answers, or okay, how you use your readings to reach a conclusion. How you use your readings to reach a conclusion. These are our readings, okay, and this is the calculated resistance. How can this be used to reach a conclusion? Take note that the load is changing, okay, you are increasing the load, okay, and the resistance will also be changing. Why? Because since the length is changing, the current and voltage will be changing. So now when you plot a graph of load against resistance, yeah, why are you plotting a graph of load against resistance? Because the question says a student investigates the effect on the resistance of a wire when the tension in the wire is increased. Okay, so that means you are interested in the tension, okay, and the what, and the resistance. What causes tension? It is the load that you are hanging, the load that you are hanging here. It is this load that you hang here that causes tension in this wire. So you are interested in the load and the resistance. That's all. So the question prompts the kind of graph you plot. So that's why I plotted this graph here of load against resistance. And since resistance is not starting from zero, then your slope is not expected to start from the origin. But you don't even need to state that. Once you just state it that you are plotting the graph of load against resistance, and a positive slope shows that the resistance of the wire is directly proportional to the load. Yeah, so when you plot your graph and your slope looks like this, it shows that load is directly proportional to the resistance. Okay, and when you plot your graph and your slope looks like this, it shows that load is inversely proportional to resistance. That simply means as load is increasing, resistance will be reducing. But if you plot your graph and the slope looks like this, okay, and you calculate your slope and you get 0 as your slope, that means the load has no effect on resistance. So this is how you interpret your graph. This is how you interpret the outcome of this experiment. So you just state it there that this is how you would reach a conclusion. Explain how you would use your readings to reach a conclusion. So if the graph is positive, then you state it that the resistance is proportional to slope. If the slope is negative, sorry, if the slope is positive, you state it that resistance is proportional to load. If the slope is negative, you state that resistance is inversely proportional to load, or you say resistance reduces as as the load increases. Load, not slope, please. As the load increases, resistance reduces. And if your slope is 0, you say the load has no effect on the resistance of the wire. That's all. That's how you answer questions on question 4 or paper 6. Okay. Any question 4, just follow this pattern to answer question 4, paper 6, question 4 on planning. I was trying to be too fast in order to finish this video within 30 minutes. So let me just slow down a bit, okay, and then explain in detail. The duration of this video will eventually be 45 minutes. That is all. We've taken this, okay, we are through with this. Let's just quickly talk briefly about another experiment. Okay, let's talk briefly about another experiment. Let's talk about the May-June 2021. May-June 2021, paper 6 of May-June 2021. Okay, yeah. So paper 6 variant 1, and that's why we have 6-1 here. Okay, and I'm not going to answer all this question here. If you want to know how to answer this question here, just visit our YouTube channel, Physics for Everybody. Okay, Physics for Everybody, and watch the video on this. So you see all the questions, answer question 1, 2, 3, and 4. But this video is all about paper 4. This video is all about question 4 rather of this paper 6. So let me just go straight to my question 4. Okay, and I'll slow down so I don't make mistakes. Talking too much, talking too fast, make someone want to make a mistake. A student investigates the rate of cooling in air of heated blocks made of different materials. I think I've talked about this, right? Yeah, I've talked about this. Heated blocks. Yeah, heated blocks. I talked about this. When you have 4 different blocks that are heated, and those blocks are made of different materials. Okay, this is what I should be talking about. Pardon me. Okay, so this is from 2000 and 2022. Yeah, 2022, paper 6 variant 1. Yeah, so that is it. The video on this is on the YouTube channel. If you want to learn all these questions 1, 2, 3, visit the YouTube channel. The emphasis on paper 4. Let's go. A student investigates the horizontal distance traveled by a metal ball after it rolls off the end of a plastic track. This is the plastic track. So a metal block would be placed here, and then it will roll down this track, okay, and here it will jump off, okay. Then it follows a parabolic path. It follows a parabolic path till it lands on what? Till it lands here at a point like this. So you might just put a tray of sand here so that you can always pinpoint the exact point where the ball lands. Okay, that's why you can put a tray of sand here. Then you measure the distance from where the ball takes off, okay, from where the ball takes off to where the ball lands. You measure the horizontal distance. That's all. So you measure the distance, then you take note of the angle of this right hand side of the track. Okay, the angle. Let's look at the procedure. The ball rolls down a plastic track. The left side of the track is fixed. The right hand side can be adjusted so that the ball comes off the track at different angles. So the angle at this end, at this side, can be adjusted so that the ball jumps off at different angles. You can make this side lie completely flat so that the angle can be 0. Then you can raise it to 10, 20, 30. You raise it to different values. What's next thing? The student measures the horizontal distance that the ball travels from the right hand end of the track to the point where it hits the floor. So you measure the distance from the right hand to the point where it hits the floor. This distance D, you measure it. What's the next thing? Plan an experiment to investigate how the horizontal distance traveled by the metal ball depends on the angle at the right hand end of the that the angle that the right hand end of the track makes with the bench. That is this angle theta here between this right hand side of the track and the bench. So once you plot a graph of this distance against this angle, then you get the slope and you determine whether as the angle increases, the distance increases, or whether as the angle increases, distance reduces from the slope. That's all. Okay, but the question does not leave you with that. The question also provides a guide. The following apparatus is available to the student. Number one, you have a track with sand, you have balls and clamp, you have a selection of metal balls. Should you use the selection of metal blocks? Since you are only interested in the distance and the angle, then you shouldn't use all of this. Only one metal ball should be enough so that you will not be varying the mass. Okay, the mass is expected to be constant. When you vary the mass, then you won't be able to work with the only variables that you need. The only variables you need are the distance, okay, this distance and this angle. Those are the only variable you might need, okay, because that's what you want to investigate, the effect of this angle on the distance. From the question, the students investigate the horizontal distance traveled by a metal ball after it rolls off the end of a plastic track. So that is what you want to investigate, okay? Good. Other apparatus normally available in a school laboratory can also be used. In your plan, you should list any additional apparatus required. What are they? Other apparatus required are you have a meter rule. You shouldn't list this a tray of sand filled with sand. Why? Because it is in the question already. It has already been stated that you have a tray of sand. Okay, so this shouldn't be in your answer. Okay, so I'm removing this, a tray filled with sand. Okay, then you may state protractor there. Of course, that's why you need to measure the angle. But always try to state only one additional apparatus because the question will always request for one additional apparatus. Okay, after that, after listing additional apparatus, what's next? Explain briefly how you will do the investigation, including the measurements you would take. Now, how will you do this investigation and what measurements will you take? Number one, what will you do? You adjust the angle theta on the right hand side of the track to be 0 degrees. So you start with when this angle theta is 0. What is it? What's next? Allow the ball to roll. When it lands, take note of the distance, measure the distance, okay? Then next, you adjust this angle theta to be 10. Allow it to roll again, measure the distance, raise the angle theta to 20, put the ball again, the same ball, allow it to roll. When it lands, measure the distance. So that is it, and that is what I wrote here. Place the ball on the leftmost end of the track and release it to roll down the track. Measure and record the distance d traveled by the ball during its flight. So after measuring the distance, what's next? Record the values of angle theta and the distance d. The angle in degrees Celsius, distance in meters. So the distance traveled by the ball during its flight. Then repeat the procedure for 4 other values of angle. So your angle will start from 0, then you go 10, 20. Yes, your angle will start from 0 degrees. After that, then you go to 10, 20, 30, and 40. After that, what's next? State key variables to be kept constant. What are the variables you keep constant? During the experiment, the following variable must be kept constant. Number one, the same ball must be used throughout the experiment. Yeah, so you don't change the mass unknowingly. Number two, there must be no drought, okay, or there must be no wind. You know, wind can affect the distance, okay? Yeah, if there is wind and the wind is blowing in this direction, the wind will be adding to the distance. The ball will end up landing here, okay? Good. So that is why you must avoid wind in this experiment, okay? It's clear, right? Okay, so let's continue. What else do we do? Let's go straight to the next question. Yeah, so that is it. That is clear. Okay, so what next will you do? Draw a suitable table with column headings to show how you would display your readings. You are not allowed to enter any readings. So this is the table. You draw this table, okay? This is the table. Put the column headings, angle in degrees Celsius, distance in meters. That's all. And what's the last thing? The last question says, explain how you would use the results to reach a conclusion. How will you use this result to reach a conclusion? Now this is it. You plot a graph, okay? From this table, use the tables here to plot a graph. Plot a graph of angle in degrees Celsius against distance in meter. After plotting the graph, what will you do? Determine the slope S of the graph. So you plot a graph here, a graph of angle in degrees Celsius, distance in meter. Then you determine the slope. After getting your slope, what does the slope tell us? A positive slope shows that the distance traveled by the ball increases as the angle of inclination of the right-hand side of the track increases. So this positive slope shows that as the angle is increasing, distance is increasing. What if when you plotted the graph, you got a negative slope? Then the negative slope shows us that as the angle is increasing, distance traveled by the ball will be decreasing. And what if at the end of the graph you ended up getting a constant value as a constant sorry you ended up getting a zero slope? Yes, if the slope is zero, that means angle keeps increasing, distance remains constant. That means angle has no effect on distance, because as angle is increasing, distance is constant. But in reality, this is the kind of slope you will get. That's all. So once you state it there, that okay, if the slope is zero, then there is no relationship between angle and the distance traveled by the ball. So that's it. You have stated how you would interpret the result of your experiment. So once you do all of this, that brings you to the end. You have answered question 4 perfectly and you get all your marks. You get all your marks, all the 20 marks for question 4, you get them without losing anyone. So that brings us to how to answer question 4. If you want to learn how to answer question 1, 2, 3, there's a sample, there's a format there. That's the video before this very video. Watch the video, okay? So I've reproduced this video again and the sound is now present. The first time I produced this video, I did not record the audio, so I had to just produce it again, okay? So just watch this video. I will have to delete the previous one, okay? Thank you very much. Ensure you subscribe to this YouTube channel and come back to watch more videos. Do have a nice day. I wish you the best and excellent grades. I wish you the best performance in your exam. Goodbye.